Hello everyone. In this video, I will demonstrate how to solve logistic regression using Excel. So I will start with the basic introduction to logistic regression. So in a typical linear regression prediction formula, this is what you have. Usually you have the predicted value and then you have the equation. So W0 means the intercept estimate or the constant, and we have W1, W2, all these are parameter estimates. And then we have input measurements, which will be given X1 and X2. And then we come up with the prediction estimate, which when you solve this one for a given value of X1 and X2, you get the Y hat, which is the predicted value. And you choose the intercept and parameter estimate in such a way that you will minimize the squared error function, which is given by this one. So yi is the actual value and yi hat is the predicted value whole square, and you sum it, you get the sum of squared error, and you always try to minimize it. So you find these parameters w0, w1, w2 in such a way that it will minimize that squared error. In logistic regression, things are a little different because now we don't have the continuous outcome like the numeric scale, but we have a binary outcome. So, for example, let's say we want to predict whether somebody is going to buy your product or not. So it's going to be 0 or 1. 1 being bought, 0 means did not buy. So for that kind of situation, we use logistic regression. And the equation here, as you see, is very similar to regular OLS regression equation here. And when you solve this equation, you get the logic score. So that's the value you're gonna get whenever you solve this equation, but that value is meaningless because our probability is bounded between 0 and 1. So we need some way to transform this logic score into the probability, and this logic function does that trick. So this logic link function transforms the probabilities between 0 and 1 to the logic scores between negative infinity and positive infinity. So in other words, when you solve this value here, this equation here for a given parameter estimates, you can get any number that can range from negative infinity to positive infinity. And you want a mechanism to transform those negative infinity to positive infinity value between 0 and 1. And that's the probability we are interested in. And this logic link function, which is this function, does the trick for us. So as you see here, the logic link function, the probability will always be bounded by 0 and 1, and your score, the logic score, can range from positive infinity to almost negative infinity. So basically, there is a non-linear relationship between the dependent variable, independent variable, and the dependent variable, which is here we're trying to predict the probability. So it's like a S curve here, as you see. And when you use the logic link function, so logic link is again this one, this code logic, this entire thing is called logic function, and that's logic score. So here, if you plot those logic score against the independent variable, you are kind of linearizing the equation. So you're transforming this nonlinear equation into a linear equation using the logic link function. And once you linearize the equation, then you can interpret it very similar to what you would do in your regular OLS regression model. So we need to obtain this prediction estimate. And so for that, we need to solve this logic link function for the value of p here. Again, so let's say that what we're going to do here is we're going to say this entire shebang here, we'll call it as logic of pi, p hat. So that's my logic score. And when I substitute that one here with the logic p and I solve it for p, I get this value here. So you can do that. So if you log of p hat divided by 1 minus p hat equals logit of p hat, which is equals to this equation here. If you solve, so if you solve this side and this side here, you'll get the p hat equals 1 over 1 plus e raised to the power minus logit of p hat. Remember, remember that this is also equals to e raised to power of logit p hat divided by 1 plus e raised to the power logit p hat. So if you solve it, if you go into the derivation, you will find those results here. So for example, here, let's say your objective is to predict the yellow dots, okay, for a given value of x1 and x2. So to do that, you need to first of all come up with the equation in such a way that will find the best fit kind of line as you always do in your regular equation. And for that, we need this estimates for the parameter here. Now, given the binary nature of the outcome, we cannot use average square error because we don't have the observed value of p here. Our observed values range are binary 0 or 1. They are not the probability, so we cannot calculate there. That is the one reason we cannot use the sum of square error. So instead of that, we use what we call log likelihood function. So we want to find this parameter estimate by maximizing these values here, which is basically the log likelihood function, which is summation of log values of p hat plus summation of log values of 1 minus p hat for each case. So using the maximum likelihood estimate, the prediction formula assigns a Logit score to each x1 and x2. So once you solve that here, once you solve the entire optimization formulation to come up with the best estimate, is going to come up with this kind of estimates here. And once you have this estimate, then you can find the probability for any value of x1 and x2. Okay. So with that, let's switch to the Excel here. I'll go to the Excel here. I have this formulation here, so I'm going to start with 1 and 0 here to start with. So let's go through it here. Let's say you're trying to predict whether somebody is going to buy your product or not, given their income. So here y equals 1 means they have actually bought the item, y equals 0 means they did not buy the item. And you have the income for every person in your data set. So your data set is around, how many values you have here? Let's say you have around 36 cases. So this is like sample size here is 36. Okay. So first of all, what we're going to do here is we have to calculate the Logit score. So Logit score here is simply given by this formula as we have seen. So I'm going to say function 2. So you see that here 1 plus 0 times 79.02. Or I'm going to do it here again. So I can say that here equals, I'm going to say this one. I'm going to fix that cell plus, I'm going to do this cell, I'm going to fix it again here times this value here. Okay. And once you find the Logit score, here we're going to take the exponent of that value here, right? So that's going to give me the exponent of that, which is basically this part here. That's called raw odd. So this is the probability of buying, odds of buying particular your product given the age. Okay. So once you have this part here, we can always, if you solve this equation here, you'll get this equation here. Like the probability will equals to e raised to our logit of p hat over 1 plus e raised to our logit of p hat. So logit of p hat is basically this value here, because that's what we found out here. So this is our logit score. If you do the exponent of that, that becomes your logit score. So here, basically what I'm going to do here is, I'm going to say this value divided by 1 minus this value here. Okay. I'm sorry, this should be 1 plus. Okay. So that's the probability we have found out, because the probability of purchase. Okay. Now, what we want to do is we want to maximize our likelihood estimate equation, and we need some explanation here. Uh, so this equation is going to max this likelihood estimation is basically telling you that you want to come up with the best possible prediction here. And what do you mean by best possible prediction? Well, if somebody did not buy the product, then we want this probability to approach to zero. And if somebody bought this item, like this one here, we want this probability here to approach to 1. And when you do that, you're trying to come up with the best possible accuracy and minimize your errors. So basically, this equation is kind of error estimation. Like in regression, you would do that. Now we are dealing with the probabilities here, not the numbers. And basically, if you do the product of all this value, that will be likelihood. And it's always easy to deal with the sum instead of the product. So what we're going to do here is we're going to take the log, the natural log of this value here. I guess I did not explain this one, how you got this one. Basically, this formula is very simple. All it's saying that I'm going to use simple if function here. If this value equals 1, then retain my probabilities, else give me 1 minus this value. So if it is 0, give me 1 minus of that probability value there. Okay, and that makes sense. So for example, we are trying to minimize the gap between the predicted value and the actual value. So if actually 0, we want this to approach to 0. If actually is 1, we want this to approach to this. I'm sorry, this to approach to 1. Yeah, that's right, this one. This approach to 1. And this formula is gonna, it is gonna help us maximize the accuracy. Okay. Now, as you know, the log of 1 is 0, and log of 0 is negative infinity. So all, if you take the log here, all these values will be negative. Okay, and when you take the sum of all these values, it's going to be negative some number. Now you want to maximize this likelihood, which means that you want this likelihood function, log likelihood function, to approach to 0. So because 0 is the maximum you can get here, and that's objective here. So when you get 0, that means you're not getting any errors. That means you have find the best fit equation. That means you have perfectly predicted all the outcomes. So that's not going to be possible, but we will try solving this one so that this approaches 0. And for each probability, we found the natural log, because we would rather deal with the sum instead of the product. Okay, because otherwise what you have to do is you have to take the product of all these values and try to minimize that. Okay, but here rather I would maximize the likelihood estimation here. Okay. Okay. So let's go ahead and do with the solver here. So this is simply, I guess I explained this one. This is simply exponent. I guess this should be natural log. So that should be natural log of this value here. And then you're just gonna copy it down. Okay. Now all we have to do is use the solver. I'm gonna use solver. I'm going to maximize this value here, G45. I want to maximize that. That means I want it to approach to zero. And by changing these two cells here, right? I'm gonna make sure that this box is unchecked because basically this box is telling me that all the unconstrained variable are non-negative. If I do that, that means these two variables have to be always positive. But these coefficients could be negative. So we're just gonna uncheck this one. GRG nonlinear should be selected here. If you solve this one, you'll get this answer. So you have maximize the likelihood. So maximize the log likelihood, which is in this case is 18.6014, and these are your best possible estimates for W0 and W1. So basically your regression equation is 7.824 plus 0.074 times H. I'm sorry, income. So that's your logistic regression, and that's how you do it in Excel. I hope this was very helpful. Thank you very much for listening.